Welcome to the CisLunar experience. I'm your host, Vincent Maroli. Together on this show, we are going to interview the movers and shakers of this new space economy. Those courageous CEOs, chief engineers, academics, and policymakers that are turning dreams into reality.
So we thought, okay, what if we shrink it down? What would that look like? Figure out what the cheapest, smallest thing you could get into space would be. How fast could you do it? What could you do in 2 years? You can take each of these modules and add them together. So it's not only distributed to different orbits, but it's also scalable. And so you can increase throughput by adding them together. So it's modular, scalable, small size thing that can then produce, a couple different products.
That was Gary Calnan, CEO of CisLunar Industries. Their company is converting space debris and space trash into reusable metal rods for the new space economy. We flew out to Denver to have a conversation. Thanks for listening in. And we're live. Gary,
Right.
thanks for being on the show. Really
my
appreciate
pleasure.
it.
Yeah, it's exciting.
Absolutely. So before we really get into all the other questions, want to tell a quick story about how I actually found you guys. So the name of this podcast, the CisLunar Experience. CisLunar, as I'm sure we're both familiar with. Let me do this. Could you just give a definition of
CisLunar space?
Of just CisLunar space.
Yeah, so I think the technical definition is the space between the Earth and the Moon, but I first came across this term when I was looking into the space industry, and I found this great blog series about CisLunar It was the CisLunar Economics 101, I think is the name of it. It was kind of very inspiring to me, actually, but the way the author described that was... It's this, from his point of view, it was Earth orbit, lunar orbit, really the whole volume of space that includes the moon and the Earth, so the Earth-Moon system, if you will. So people who don't understand what that means because they're not, space people, I say, imagine if you had at the center of a ball, you put the Earth, and you inflated that ball so it was big enough to go out past the moon. Nice. Everything inside that ball is CisLunar space.
That's a great example. I was just going to do the Webster definition, so thank you for that. Right, so it's a geographical location. That's the name, plus more, and I think it's going to be one of those phrases that is people hear a lot more in the next decade. And so I had this idea for this podcast, and I thought, well, I want to encompass all of this space in this region. It's going to be a video and audio. Let me look up on LinkedIn, CisLunar, and I found you guys. I was like, who the hell is this guy? He stole my name. I mean, he had it first, but still. And then I started, stalking the website, seeing your previous posts, and realized that you guys are doing some really, really cool stuff. So that's, I guess, how I first reached out in November or whatever it was.
Yeah, I guess around the time... shortly after we did our demo last year. Is that about that time frame?
I think so.
Yeah, that sounds about right. Yeah.
Nice.
I didn't realize that's how you found us, actually.
Yeah. Just looking at the names. Yeah. So it was good stuff. Well, cool. So then I guess first other official question, walk us through for myself and some of the audience. What was that first space aha moment for you back however old you were up until right before this new venture with CisLunar Industries?
Okay, so the earliest memories kind of thing? Yeah, sure. Yeah, so I've always been fascinated by space as far back as I can, probably not as far back as I can remember, but I have very early memories of, I think my earliest memory around space was the Challenger incident. So back then, let's see, I was born in 78, so that gives you some time frame of, I was at that age, at the time of Challenger, I was in kindergarten time frame, something like that. They used to take us all out into the, this middle area in the, in the school. There was a bunch of classrooms around, kind of almost like a cul-de-sac, but inside the school. And then they would sit down on another chair, a small TV, and sit the kids down on the floor, and we'd watch the shuttle launches because it was so special back then. A shuttle was pretty new, and that one, of course, was very special because there was a teacher going up, and it was supposed to be like, if that hadn't happened, that was meant to be, the opening up of space for like non-astronaut people, right? And of course, we know what happened with the Challenger incident and changed everything. But interestingly, around that, I remember the scene of like being on the floor and in the TV. I don't actually remember seeing the explosion. I mean, I've seen so many footage of it later that it's stuck in my mind, right? But
right. What's memory? What's you filling it in?
But the one thing that I do remember is sort of how the adults were afterwards and how upset people were. That's kind of it's more of an emotional memory, which is how most memories, I guess, really stick in your head anyway. But so that's sort of that was kind of my earliest memory of space. That situation didn't exactly turn me off, obviously, to space. I mean, it's just one of those things that happened along the way here, unfortunately. But but as I progressed through, growing up, I became one of these kids who had like all the popular science issues that came out, and I saved all of them, much to my parents' chagrin. I took up whole shelves in the basement of, and I don't know what, they're probably in the dumpster a long time ago, but they were there, right? So that sort of gives you an idea of the personality I had as a kid, and I always wanted to be an inventor growing up. So that was, when I was very little, I wanted to be a dump truck driver, but then once I got beyond that, I wanted to be an inventor. And so I do have the next memory I have that's kind of along the path is somewhere around the age of, I want to say like 12-ish. I remember I used to take graph paper and draw things on graph paper to like ideas I had and inventions, whatever. And I remember taking multiple pieces of graph paper and like taping them together and making this big piece of paper and drawing a moon base with all the things I thought should be on a moon base, And I'm pretty sure there probably was some program announced, in the late 80s or somewhere on the time frame around this type of initiative. And there was probably an article in Popular Science that kind of inspired me. I imagine that, but I don't know. I really wish I had that picture now because it'd be something to put up in a frame in the office. But anyway, so that's kind of like the early days. I had this desire to go there to build things for that, I guess. And I didn't know, how I would be involved, but I just wanted to be in some, eventually go to space, and I still do. Yeah, so that hasn't changed. Nice. And then, as my life progressed, at that time it was still the province of, countries to go to space, right? And you had obviously companies build things for governments, but it wasn't like it is now. There wasn't a lot of, commercial rocketry happening, right? There were efforts to do it, but it wasn't really happening. So, as I progressed through high school, like my desire to be an inventor and to go down that path continued. And I ended up going to the Air Force Academy. And part of the reason I went to the Air Force Academy, decided to go down that path, was I saw it as a way to become an astronaut. And so in my mind, I was never wasn't my dream to go to the Air Force Academy like it is for a lot of people who go there. But I had the opportunity to go. I applied, I got in, and my thought was, well, I'll go there, I'll get an astronautical engineering degree, I'll become a test pilot, and then I'll become an astronaut. So, it's a path.
Yeah. It's the traditional one.
Yeah. And it's probably a very typical cadet thing to think they're going to do. I mean, I don't know what percentage, but I'm sure it's not uncommon. And then from there, I found out after about a year of being at the Air Force Academy that this was not a life for me. And, I was in Colorado. I stuck it out for another year after that, but right before my junior year would have started, I left and I went to CU Boulder. And in that transition process, I stopped doing engineering programs, and for a variety of reasons, but part of it was not really appreciating the difficulty of transitioning from military controls to total absolute freedom. And as a 19-year-old, you can kind of figure out where that went. But anyway, I ended up going down a different path, and I got a business minor and an economics degree. And so my way of becoming an inventor at that point was to be an entrepreneur. And still at this time, space was still the province of governments. This is like 2000, right around that time frame. I graduated in 2001. I had a startup company at that time that I carried forward, and I went through a whole career in finance. But what I noticed is around, I sort of watched as SpaceX became a real thing and started to make the news. I was always keeping my eye on space, and I wanted to find a way to get back in. I had this like deep feeling I needed to get back into this. I needed to get into the space industry, not back, I guess. And I just didn't know how to do it. I was in a finance career. I didn't want to go into the finance department of, say, a big prime or something. So, I almost went back to school to get an engineering degree because I was like, I should have been an engineer, and then I found out about International Space University around, I would say that was around 2016. And I found out about it because I read a book that Peter Diamandis wrote called Bold, which sort of helped loosen up some thinking in my mind about what was possible for me. And then because he was one of the founders of ISU, I learned about ISU, and then I saw that as my way in. And then in 2017, I went to the Space Studies program at the International Space University,
Gotcha.
which is where CisLunar Industries was born as an idea.
Okay.
So that takes you from the beginning to now.
No, I appreciate that. So a couple ideas coming in there. I'll put a pin in the from CisLunar Industries on. Mm-hmm. You had another startup.
Yeah.
A couple years earlier from that when you were younger. Something about ride sharing for
sort of, yeah,
drunk driving.
Yeah, kind of. So when I was at CU, I had a common problem that many college students have, where we didn't live close enough to walk to the bars, and we would find ourselves like driving down to the bars and having too many drinks and leaving our car behind. And so it was like, well, somebody should be able to drive your car home. Wouldn't it be great if somebody else could drive my car home for me? And we're like, oh, well, that could be a business. And so, we saw a need and tried to build a company around that. The company is called Night Riders. We had one of the unique things about it was, there was rules around taxi cabs. Uber didn't exist at this time. This was 2001 when we started the company. Okay, so I was like right in my senior year of college where this was starting, and then I went straight into that after college was over, and we had these mini motorcycles that like could fold up. Some of the early ones could fold up, but the ones we landed on at the end of the day was this mini motorcycle that could break down into 4 different pieces, and each piece would go into a bag and it would go into the trunk of the car. So the idea is a driver could drive out to you on the motorcycle, put it in your car, drive you home, take it out, put it back together, and go to the next customer. Right? And it was a very traditional dispatch system. We had actual employees. It wasn't like a Uber model where you have everyone as an independent contractor, because we wanted to control like when they came to work, what they wore, and all that stuff. That we just thought it was a better way to do it. It was a very difficult business model because your demand is very narrow window right at the end of bar closing for the most part, and you have people employed for longer periods of time. And so anyway, we were able to grow the company to a point where we raised about $300,000 from angel investors. We taught ourselves everything that we needed to know about business, because I really didn't know much. Basic courses, right? And then we ran that for about 4 years, a little over 4 years. Took many hundreds of people home safely, and almost made a profit. But eventually we ran out of money and we couldn't raise, the next amount of money that we needed. And, eventually the lights just turned out effectively on us. I mean, it was an interesting experience, though, as a first proving ground for entrepreneurship, because I was completely wedded to that business with my personality. What my personality and the business were like one and the same. There was very little differentiation. Yeah. So and there was no plan B, and I had very little to lose because I was straight out of college. So it was like go for broke. And when it broke, I was like, oh, now who am I? Yeah. So it was, a good lesson, and I don't think it's that uncommon for entrepreneurs to go through that with their first startup, because it's just such a you get it so deeply enmeshed in it, especially at that age.
Well, it's also an interesting dichotomy, because very similar in my retrospect. Left the finance job to make this podcast a reality, and just like you at that age, responsibilities are as much as I put on my shoulders. Right? Don't have the wife, don't have the kids. There's a lot of freedom there. The downside, and what I've seen is, like, statistically, if a company succeeds, the founder is probably somewhere in their 40s, and like just
The odds are better, I guess.
the odds are a lot better there. From your own experience, is that just because now you've got, your base level, you've been in the career a little while?
I mean, I think that there's some wisdom you gain over the years, of course, that you can't, it's hard to, I mean, especially if I was telling myself at this, like my younger self this now, I don't know if I would have believed myself. I mean, honestly, like, yeah, well, what do you know, old man? I mean, I always appreciated the wisdom that people brought to me, but I thought I could figure it out, and I figured a lot of stuff out, right? But so part of it is, it's sometimes hard to quantify, I guess. But I mean, I went to normal corporate jobs after that, and I learned things from big companies that I was reinventing the wheel for when I was doing my own startup because I just didn't know. So there's a little bit of ignorance that you overcome over time. And then the other thing, you have some different perspective. So like, at the time I might have been more nervous to approach, say, another executive or an investor, although I was pretty confident with that business. So that's part of the reason why we got investors at all. But
yeah, it's $300,000 as a 22-year-old. That's pretty good.
By all accounts, no one should have given us any money because like we really didn't know what the hell we were doing.
Nice.
But we had a lot of passion.
Love it.
And we believed in it. And that came through. But I mean, now I have obligations. I have mortgage. I have family. I have a daughter. I can't just like throw it all on the line. And I have to respect the needs of my family. And so in some ways that allows you to maybe think more long-term and strategically about how you approach it.
Sure.
And not that you couldn't do that as a right out of college person, but I think I was a bit more impulsive then than I am now.
Fair. Yeah. So I guess transitioning from that to actually figuring things out, walk me through the genesis of that, pizza and Red Bull, whatever the conversation was in someone's garage. Hey, we should start a space, that we should start CisLunar Industries.
Yeah, so the way that came down is when I was going to International Space University, I had decided basically that I wanted to get back into entrepreneurship. So I was sort of bored with the corporate lifestyle. I found that I had a pretty good job. I was a director of finance for a mid-sized SaaS software company here in Denver. Made a decent salary. The company was like a $200 million revenues kind of company. So, it was, and I was in a position where I got to be involved in a lot of stuff. So it was a good job. But nevertheless, I found that I was probably at the end like allocating 30% of my intellect to that job because I was just bored with it. I needed there's something about people who do these things, and I certainly count myself among them, where I don't know, like the risk and the risk of failure and like, whatever, things blowing up in your face is somehow motivating and gets those certain chemicals, juices flowing in your brain that are rewarding for whatever reason. And so anyway, I knew that I wanted to get into entrepreneurship. I quit my job as a director of finance, not in a way that I couldn't come back to, but like I didn't want to take a sabbatical, which I could have done because they appreciated having me around and they would have given me the sabbatical. But I wanted to not burn my boats, but send them away. And I did that. And I quit my job. I left. I was able to negotiate a nice, severance as I was leaving because of certain things that were going on at that time. So that sort of helped with smooth things over with family situation and all that. And then, so I guess I went in with that idea that I wanted to do something. I knew that I wanted to be, just to put some context around it. At the time also, Planetary Resources and Deep Space Industries were basically making asteroid mining look like it was going to become a real thing. And they really blazed that trail. And at that time in 2017, they were still flush with cash by all accounts that you could tell from the outside, right? And so I thought, damn, like this thing is happening now. This thing that I've been reading about in science fiction that I wanted to make a reality is happening now. And I want to get in on it. And I feel like this is like the very beginning of this huge wave that's starting. And these only happen a few times in any one person's life where you have these big moments. Kind of like when the internet became a thing in the 90s. Like I was too young to do anything about that, but it felt like that again, right? And so I wanted to be out there. I took that step to say, I want to be on the frontier where people, where humanity is going to be expanding out into space. I didn't know exactly what I would do. But I did think of the name CisLunar Industries before I went to ISU because I had learned about CisLunar Space from that author and that series that I mentioned earlier. The website was available, so I bought it, and I'm like, I don't know, I'll use it later, maybe, And then I went to ISU, and I went there with the goal to find other people who would be co-founders with me, to do something out on the frontier of space, of human expansion into the solar system, and ideally in my mind, I was like, wouldn't it be great if we could also find funding?
Yeah.
I mean, sure, why not?
It'd be nice.
I didn't
These
really
things
appreciate
cost
how hard that was going to be, but anyway,
Yeah.
these are things you learn. So when I was at ISU, it literally was like, as I was going through the program, it's 9 weeks long, the program I was in. And I just took every opportunity when we were socializing and getting to know different people to find out, like, hey, are you interested in doing something entrepreneurial? What is your background? Is it complementary to what I have?
Nice.
And I found some people who were doing things or had some experiences that I thought were complementary, who were also interested in doing what I wanted to do and being out on that frontier and doing something with resources. And then we literally just went into a room one day when I got the core first few people, went on a whiteboard, kind of said, okay, if we're doing space resources, on one end, we've got the people doing mining right now, planetary, deep space industries, some companies doing things on the moon, like iSpace was talking about mining the moon and stuff like that, sort of, in some of their, communications.
I remember that.
And then you had Made in Space doing in-space manufacturing, and, Tethers Unlimited and some other companies, but really it was Made in Space was the highest profile one that I knew about.
Yeah.
And then we looked at that value chain and we said, okay, well, what else is in here between these guys and these guys? And, there's people talking about processing water, of course, to turn that into propellant and water for drinking and other things. But really no one spent a lot of effort talking about processing metals. And, the mining companies would say like, okay, and we'll use the metals, but it was not much of a plan as a focus area. And so we thought, well, any industrial economy needs to have a metal processor. There's a piece in this value chain that's not occupied, or it's at least not crowded, we should look into that. And so we started looking into that. And then I personally became more aware of space debris as a reality. And so that it kind of clicked like, okay, well, why isn't anybody mining the debris field? Like, you already have this refined metal. We know kind of where it is. We know who owns it. So it seems like we should use it instead of just wasting it, right? And that kind of led us down that path. But that's sort of you described a garage moment. It was in like this, university setting where the program was, and that's how it happened.
It's interesting because without knowing that story, I was thinking, well, maybe they saw the need to clean up space trash first and then looked to fill that gap. But instead it was, we want to have a CisLunar economy, and we need metals.
Yeah, it was like, well, we want to be industrialists in space.
There it is.
And like, this is, well, CisLunar Industries, right? There you go. So it was like, somebody's got to build the steel mills of this future economy, and no one else is doing it. So what would it take? And then at ISU, we had all these experts that we could tap into. And we just kept asking people questions like, hey, how crazy is this idea? What would we need to do to be able to do it? And we started to think about like, okay, well, what would a system that was doing this, what qualities would we want to, would be desirable? You can't maintain it like you can a steel mill and so on. So there's a lot of stuff we can dig into there if you want. But.
For sure. Yeah. Excuse me. One of the things just on industrialism, I love biographies of Carnegie, all those guys. And it's interesting that even here on Earth, once a country is able to produce its own steel and it no longer has to import, it reaches a different level of economic freedom, because a lot of people can produce steel.
Sure. Quality steel? A little harder.
But if Zimbabwe can now produce quality steel, then they can probably build their skyscrapers, their bridges, their tunnels a little easier. I don't think Zimbabwe can do that yet. I'll have to check on that. So it's clearly a pivotal piece in that industrialization. So I guess digging into how you guys want to do that. We talking just straight on the moon, or just in that CisLunar space? Walk me through, I guess, maybe the short and the long-term vision of.
Now, I can tell you like some of how we came to the method as well, which might be give
Sure.
some context around it. So as we thought through it, was thinking, okay, you're in space. It's not going to be easy to service this thing. Right. You probably don't want to have it where people are, because that like 10x is the cost of doing business. And so, it needs to be something that'll last a long time. Well, what kinds of things make things wear out? Well, contact makes things wear out. This is just like kind of, we didn't know anything about this really. So we're just kind of logically thinking through it. So we started thinking about, well, what kind of contactless processing could we do? And it turns out that on the space station, they have, maybe there was some Q&A that we did with some of the advisors that kind of helped us think down this path as well. But they have this electromagnetic levitation furnace on the space station. They've had it on there since the beginning of the space station. And even before that, they had flown a similar device on the shuttle. And it's just really small, like 8 millimeter in diameter, spherical samples of different materials.
Gotcha.
That they can, levitate. But I put levitate in air quotes because like you're not actually levitating it in microgravity, you're just positioning it. But they would hold it in a position. But anyway, they did a lot of material science. So that was one thing that we learned about in our research of cutting edge. Sure. There's also a facility called the Electrostatic Levitation Facility that the Japanese Space Agency has on the space station. And it can levitate even non-conductive things because it uses electrostatics and then heats it with a laser. So we didn't want to go down that path because we were thinking about metals and it seemed easier to do the electromagnetics. So that was like started to get us thinking about, okay, contactless could be a way to do it. And we still are thinking about contactless as a desirable feature. And we use that for some of what we're doing. But you asked a more general question about where is it and how would we do it? So that was kind of the beginning idea. Then the next question is it feasible with the space debris that's out there as our first, feedstock? Because we're not mining asteroids yet.
No.
We're not mining the moon yet.
Nope.
Okay, so that's still ways out. But we do have space debris, and we need to get rid of it. So let's use that as our first feedstock. So then the question was, okay, what about the orbital mechanics of these objects, where they are, right? And it turns out that, yes, right now there's something like just under 10 million kilograms of mass on intact objects in space, or roughly intact. Some of them are broken up a little bit, but it's dispersed around, lots of different orbits. And this is not uncommon or not that different from a terrestrial recycling problem where you have lots of material out there, but it's a matter of aggregating it to a place where you can use it, right? Sure. So as we did some analysis around this, and I didn't know anything about orbital mechanics when I was going into this either. So there's like breaking through layers of naivete, basically, or ignorance around different things. It seemed like it was going to be difficult to do anything in LEO because even if they're in the same inclination, they could be in different positions around the Earth, but at the same angle. Okay. So, and then we looked at that, and we looked at the geosynchronous orbits, which is where, like, for people who don't know, that's like where the communication satellites are, like DirecTV and stuff like that. So that actually seemed to be the place to go because you've got all the satellites relatively in the same plane. We were looking at this relatively circular orbits that were in that area, and there's a fair amount of upper stages that are up there that we could go after. Okay. And then inside that there's just under 500,000 kilograms of mass in relatively circular geosynchronous orbit. So that was kind of the path we went down. In the beginning, it was this: let's build because back then there wasn't a whole bunch of debris removal companies. There weren't a whole bunch of people proposing private space stations. So our thought was, well, we'll build a platform, like a communication satellite size platform, something like 5,000 kilogram size. We'll do 20 or 30 kilowatts of power or solar power. Okay. And we'll have, robot arms that can birth material that's brought to us by other companies. Because there were talk about satellite servicing spacecraft or space tugs out there at that time. And we'll have sort of a big platform that we'll do processing on. And
one centralized location sort of thing?
Well, maybe one or two, but if you're in GEO, actually, you can have just maybe one main platform because you can come around the GEO belt just by getting out a little bit further in your orbit or a little bit closer in, and you'll just drift around and sync back up with it pretty quickly, depending on how far out you go.
Okay.
So that's feasible. And then there's another aspect of it that kind of helps, which is we can use some of the materials that we're processing as propellant. And that we'll have to dive into that aspect in a bit here, but just take it on faith that you can use it as propellant.
Okay.
And if you can, then you can drive the retrieval of everything with some of the debris that you're retrieving. So we had figured out the math on all that, and it seemed very feasible. Like you only needed 25% of the mass to drive the whole process, and the rest of it could be used to build stuff with.
Okay.
So that was the basic, high level calculation we did. The problem with that was we're very new startup. We don't have funding yet. And we're talking about something that's probably a couple $100 million at least to build this thing. And, we were pitching the Luxembourg government. They had their space resources initiative that they had announced. We had most of my co-founders weren't American at that time. And so, it made sense to start it out over there.
And Luxembourg is cutting edge for Europe.
Yeah. And especially in space resources and commercial space, right?
Right.
So we thought it was a good fit, and they liked what we were talking about, and we went through a couple proposal cycles with them. But, really, we couldn't quite get over the hump, and we went through some different iterations of what that facility would do to try to make it more commercially realizable in the near term, because it's also who's going to buy the stuff, right? That's kind of how it started out. So it was this centralized platform in Geo. And the reason I'm telling you this background is because it leads to the next step, which is we decided that it would be worthwhile for us to come to the U.S. and try to pursue funding here. There's obviously a lot more funding in the United States, both private and government, than there is in Europe. And so we moved the company to Denver in 2019. And around that same time frame, we had this realization that, well, what if instead of making one big centralized platform where you process everything, we made a distributed platform? Sort of go along the lines of the thinking around like CubeSats and, mega constellations, right? Shrink it down, much lower cost, launch a lot more of them. And what if we could spread out the processing capability to where it was needed? Well, if we did that, then we could do it in LEO. You don't have the same orbital mechanics problems. You're not moving things many, many degrees around, in different orbits to get there, which is costs a lot of energy to do that.
Right. Because that's just digging into that one side. That's something that just in the past 6 months or so, I've realized that LEO has a lot of different areas in it.
Oh, yeah.
And there's all these different inclinations for things to orbit that you may still be at the same altitude above from Earth, but you're never going to be able to rendezvous with such and such orbit.
Not without spending a lot of energy.
A lot of energy.
Right. Right. Yeah. Yeah. So, it was like that aha led us to the concept effectively to where we are now. So we thought, okay, what if we shrink it down? What would that look like? And I actually had a conversation at one point prior to that with another space CEO at a conference I went to, and he's like, what you guys need to do is figure out what the cheapest, smallest thing you could get into space would be. And how fast could you do it? What could you do in 2 years? And it would move the ball forward a little bit. So that idea, plus the thinking about the constellations and how could we get to LEO, or really where the action is happening now for commercial stuff, led us to this concept for now what we call the microspace foundry. Okay. So we went from big grand platform, right? Now we're down to the microspace foundry, which is, meant to be less than 100 kilograms, maybe 150, somewhere in that size frame. It'll use less than a kilowatt of power, and it's it'll be able to process 1.5 kilograms of metal per hour. So it can produce a fair amount, but not like if you compared it to a steel mill on Earth, right?
Sure.
But you can take each of these modules and add them together. So it's not only distributed to different orbits,
Gotcha.
but it's also scalable.
Yeah.
And so you can increase throughput by adding them together. So it's modular, scalable, small size thing that can then produce a couple different products that we're looking into.
So that now the micro version of that's a like a long suitcase sort of thing with dimensions on that.
Yeah, we're looking at something like about 0.5 meter in length, and maybe 10 to 15 centimeters in a square shape, sort of dimensions. If you imagine a square that's either 10 or 15 centimeters in width.
Gotcha.
Yeah, something like that.
And for all the Americans out there, just space uses metric because it's better.
True. Yeah.
It's just a better. I love the United States, but metric system for sure. So okay, so
Easier math.
yeah, so half a meter. Okay, little cube there, and that's just the foundry. So is that going to be operating out in a vacuum, or what does the containerization of it look like?
Yeah. So, one piece of that puzzle, that process that we went through is as we came across that idea, in 2020, late 2020, NASA also had a solicitation for a SBIR proposal, this was now perfectly set up for that proposal. We submitted that proposal to them, and now you asked me how's it going to be contained. The reason I'm telling you this is because we did some experimentation during the SBIR. So we won that SBIR proposal.
Okay.
And that was at the beginning of March or 2021, March 2021. And then we started that project over the course of last year. During that project, we figured out one of the things we wanted to test was, could we operate it in total vacuum? So we were able to use the vacuum chambers at the Colorado School of Mines, who partnered with us on this SBIR. And they've been really great partners to us all along this whole process, but really now we started to actually put it into action. And so they've got a great lab there at the Space Resources Program at Mines. And, we were able to kind of draw it all the way down to, not as ultra high vacuum, but we kind of figured out that we didn't need to go there because we started to see what happened. So we were testing out aluminum 6061, which is one type of aluminum alloy. It has, in addition to aluminum, it has magnesium and some other metals in there. And different metals have different evaporation points. So just like water or ice will evaporate if you lower the pressure enough straight from ice to a gas, metal also will evaporate if you lower the pressure and you heat it.
Wow.
Okay. So this is probably unexpected for people who aren't familiar with this, but when we started to melt that metal in a vacuum, we found that the magnesium, which has a much will evaporate much more easily, just came right out of the alloy and just coated the inside of our little tube that we had around. And this was not necessarily unexpected. Like, we were warned that this might happen.
Sure.
By talking to some other people who'd done other experiments, with vacuum and metals and stuff. And so, because of that, unless we're trying to distill different, elements out of a metal, we don't really want that to happen.
Okay.
So
it's in there as an alloy for a reason.
It's just easier for us. Our goal is not refining here. It's reprocessing.
Fair.
Melting things down and turning into another shape.
Got it.
So for that goal to be achieved, we think we're probably going to put it in some small level of atmosphere.
Okay.
And it will be something that you don't need very much to achieve the level of pressure that overcomes that evaporation of various metals. So we think we can bring along like a neutral gas, and we might be able to recycle it and reuse it every time we get a new batch of material in. Okay. But it will require probably some kind of chamber, unless we can think of another solution. But
okay. So chamber up there, small little module or something pumped with nitrogen or something to that effect.
Whatever makes sense for, different noble gases might behave differently with different metals. So we'll pick the one that makes sense for the application that we're doing.
Okay. And then that container, do you have like partnerships with other people to help build those, or CisLunar, you guys want to build the half atmosphere pressurized container and launch that as well?
So the way the architecture would work is, and this is actually a crucial point, we're very focused on the furnace part of the process. So if you think of you got to put this into context of the whole recycling value chain, because we need all parts of that to be there to work, and this highlights the part that we're doing and the part that other people are doing. So our system will be a self-contained processing system and production system. So we'll be able to take input materials, process it, melt it down, and then, shape it into other products at the end, whether that's a rod for propellant or for production like an ingot, or whether it's a like a wire for 3D printing, or if it's like a sheet metal or whatever. Think of different kinds of intermediate industrial products you could make out of metal that you might buy from a steel mill. That's the stuff we're going to make. And that piece will be ours. If that needs to have a vacuum chamber, or not a vacuum chamber, but a pressure vessel around it that's for some light amount of pressure, we'll have that as part of our system. And it'd probably be pretty small. I mean, we're not talking about a big vacuum chamber here or anything, but
because it only needs to be in vacuum as it's hot and cooling, right?
It needs to be in pressure when it's heated. Yeah,
when it's heated.
As it starts to cool, it could probably go to vacuum at that point.
Okay, which might also mitigate. You got a big container, 20 rods of hot iron in there. That's gonna get a little toasty.
Yeah, I mean, heat is definitely going to be a challenge. It's also a benefit in some ways too, because once you get that melt created, it'll take less energy to keep it molten, because it will. Vacuum is a terrific insulator. So you don't, it's going to be more about how do we get rid of the heat we don't need, but we'll try to reuse as much heat as we can in the processing, process, I guess.
Sure.
The remanufacturing process, recycling process.
So okay, I see that, because you take it from whatever jagged cuts, you melt it down, you've got a rod, but let's flash forward 10 years, you've got a customer that wants sheet metal to build new space hotel. If it's still hot, you don't have to add a ton more energy to roll that out.
Oh, no,
it's in vacuum.
No, that's not what I'm saying. What I'm saying is that, maybe it goes like that, right? But it'll go from its molten state, and then it'll be, I guess, extruded or pulled into different shapes that you need it to be moved into. It's kind of a continuous casting type of methodology.
Okay.
And at that point, it will make the sheet that we want it to make. It will be cooled as it goes through that process enough so that it holds its shape.
Okay.
Because you want it to do that. Now, if we need to roll it again a couple times, which we might need to do to achieve different kinds of grain structure or whatever the type of material properties we want for that particular sheet, then we could have other rollers after that. And of course, that might be beneficial to have that capability.
Okay.
But yeah, so that would be. So you were asking about the heat piece. So there is a need to deal with that heat for sure, and we can do that with radiators and heat pipes. Whatever extra heat we need to get rid of, we'll have some radiators, and they might be fairly large, but it's not beyond current capabilities in space. Okay. And if you have things in a shadow, that gives you a nice black body heat sink that you can put things into, but it's still radiation heat. It's not like
conduction.
You can't conduct it away past the outside of the spacecraft, because now you're in vacuum. So there's nothing to carry it away from there. I mean, you can conduct it inside the spacecraft to the edge, but then it's got to get away from there somehow. Yeah.
So that's always one of those weird things, like talking about the moon, right? It temperature swings from 220 Fahrenheit to, negative 200 or something.
Right.
But there's practically no atmosphere. So do you experience the heat? Do you experience the cold? Sort of is the answer.
Yeah. I mean, so that's the heat problem. But I think we had started off on a path of talking about where our piece is and where the rest of it is.
Yeah.
So we've got our piece that's that foundry part, right? But to make all of that work, we need to have the whole ecosystem, from collecting the debris or some other feedstock. If it's not debris, it could be metal launched from Earth. It could be metal that comes from the moon. It could be metal that comes from asteroids. But in the beginning, it'll be probably space debris.
Sure.
Somebody's got to go out and get that. That won't be us. We're not building the space trucks. Okay. Then it's either got to come to a place where we do the work, and that would be like, if you imagine like an industrial park where you have your recycling plant. So this is going to be space stations that other companies are already working on. Like, Nanoracks has an interesting concept that called Outpost that we've been looking at as a possible way to host this, but it could also be on, the upcoming what's it called, the Orbital Reef one that Blue Origin and Sierra Space are working on, amongst others. And then you've got Northrop Grumman that has one. There's a number of concepts out there. I mean, ranging in interesting, like conventional to exotic kind of ideas.
It's finally happening.
It's finally happening, and many of these are even the ones that seem kind of further out there, I think, are quite plausible, actually. But so all of these things could be hosting for our platform. They're the real estate.
Okay.
So we just want to buy space at these industrial parks
Nice.
to host our capability. They'll supply us with the power and the communications as part of the utilities that we buy from that commercial park. We'll pay the trucking companies to bring it to us, and probably to deliver the goods if they need to go to another platform or something.
Yeah.
The other configuration that we talk about is where, you imagine you have a debris removal spacecraft, and it just needs to remove debris. It doesn't need to do anything with it. We could put the Space Foundry on there, and it could make propellant for that piece of that spacecraft.
Sure.
That enables it to remove propellant as a limitation from the calculation. So instead of getting 5 missions or 4 and needing to find a depot to refuel at, it basically can refuel itself as it goes. And if you're just trying to remove debris and deorbit it, that could be an interesting configuration as well. And there's some other applications for this sort of configuration that are possible.
Yeah.
But actually, it makes me realize we haven't really talked about the propellant part of this yet.
I was about to bring us to that. So yeah. So one question I've got in my mind, and this will be a transition into that. From one perspective, this is a vulnerable position to be in for CisLunar Industries. You're one piece of a value chain, and the other 12 or whatever, none of them are actually working and up and running, or very few of them are. Yet. How is that a strength?
Yeah, I mean, the way I look at that is, if you look at modern economies on Earth, which is where they all are right now, you don't have these monoliths that own the entire, production chain like Ford did back in, in the beginning of the Industrial Revolution, right? A diverse economy makes it more robust. So yes, in the sense of having a risk that we aren't building our own platform, we aren't building our own space trucks, we are reliant upon partners to do that work for us.
Sure.
I believe that a bunch of these companies are already working on it. They're already investing in it. That means we don't have to invest in that technology also, which means we can all get there faster. And by us being in the middle of this picture, we make the work that the debris removal companies are doing that much more valuable, because now that waste that they're trying to get rid of has a market value as a commodity, which changes the value proposition for them. It creates a use case for the platforms, right? It feeds materials in to build those platforms with and extend them, grow them, make them bigger, do different things with it, right? And then all these things together just create a much more robust, dynamic economic system that's driven by having, just the normal economic incentives that we've seen our economy grow with so far on Earth. Applying the same thing to space means that there should be diversity. And many companies in every vertical, probably including metal processing for that matter, that will help to make this robust system happen, which means that even if one of our partners doesn't make it, there'll be another one that we can use, right? It's not going to be like a one-stop shop.
That's fair. And yeah, I mean, we even see that in the space industry, right? The SLS launch system, space launch system, just finally rolled on out into the pad. It looks really pretty. It's a really expensive piece of hardware that you can only use once. There's some benefits to it, but it is a little frustrating that it can't be reused. But that's because it's on the old model.
Yeah.
Right? It's been 20 years.
The government-run model. Basically.
Right. Yeah. Or if you compare that to what NASA has been moving more towards, which is, hey, we'll be first customer. Mm-hmm. We'll do grants and stuff. Then all of a sudden you see the difference between SpaceX and ULA, where they said, hey, we wanted you guys to develop a human-rated system to get astronauts up to the ISS.
Right. 2
different competitors. ULA just crapped the bed twice. Weren't able to do it. They're still working on it. Maybe they've fixed their software.
To be fair, I think it was Boeing actually that had the problem, not ULA, because the rockets that launched that capsule worked fine.
Okay, I did misspeak that. Yep. Fair. Yeah, because that's where the distinction is.
Boeing does own ULA, and so they're all kind of mixed together. But
but to that point, there was multiple providers.
Right.
And so we haven't had to pay Russia.
Right. Which is pretty critical right now.
It's pretty important.
Yeah.
So good to have those. So actually, before jumping into the fuel, because I do want to get there, SBRIs, TRL levels, those are both going to be acronyms that we talk a lot about. Mm-hmm. Can you give us a definition?
Yeah,
in like the process, I
right.
guess.
So the SBIR program, and this also speaks to the value of having government in there. I mean, that's sort of from the comments we've made so far. You might think that like I think that the government shouldn't be involved in space, but the reality is we need their support to both be that anchor customer and to help mature technology in the early stages, so that it's easier for investors to get on board, and then gets to a point where commercial companies can use it and feel confident that it's going to work. Because space, is relatively expensive still. It's still very expensive now, but prices are going down, but it's still very expensive.
Yeah.
That means that aerospace companies are conservative. So these technologies need to be matured. So one of the things that NASA does, the U.S. government does, is they have this SBIR program. It runs across all agencies, but the NASA one is the one that we got. And it means Small Business Innovation Research. It's a contract. It depends what agency you're with, but at NASA, they structure it as a contract. Sometimes it's structured as a grant.
Okay.
But, at NASA, it's a process of a phase one, which is like a relatively, low dollar bet on an idea that's very early stage, that fits something that they're trying to develop. So in our case, there was a call for, this is like in the whole on-orbit servicing, assembly, and manufacturing, which they call OSAM area. And, they wanted to explore ideas for recycling metal that's scavenged from large objects outside of the space station. So this is like, whoa, this is exactly what we've been talking about since 2017.
Yep.
So anyway, it was like right up our alley. And they have a bunch of topics like that. I mean, many, many topics. And so companies can look for things that fit what they're working on or that they think they can do. And you can apply for it with a proposal of how you're going to solve this problem with your creative idea. You get 6 months and I think it's been increased now this year, $150,000. When we did it was $125,000 to achieve that goal. You have to
The 6 month goal.
whatever goal you lay out. So like usually you're not trying to create a piece of hardware necessarily. You're trying to create usually a feasibility study and maybe a little bit of prototyping, generally but it depends on the call as to how far they want you to take it. And then you do that, that helps to advance it to a certain point. I mean, we got ours to, I would say, just under TRL 4. So TRL stands for Technology Readiness Level. Mm-hmm. And this is just a scale that NASA uses. Actually, all the agencies use this. Sometimes they're a little different between, on the nuance between the different agencies, but it's basically the same thing. And it goes from 1 to 9, where 9 is like, it's flown in space. We know that it works. It's been used a couple times. It's like proven hardware, right? 1 is like, I have an idea on a piece of paper. Gotcha. Maybe. Yeah. I have an idea.
I've got a couple TRL ones.
Yeah. And so I think when we did ours, we had, you have to look it up to see what the difference is. I can't remember off the top of my head, but, we increased ours from TRL 2, which at that point it was like, we had a concepts drawn out. We had done some, basic study to vet the feasibility of it at a conceptual level. Mm-hmm. We hadn't built any hardware yet.
Okay.
And we hadn't really even tried to build hardware or anything. It was just like kind of thinking about it, testing it out. And we got it up to just under TRL 4. So, and that's sort of like you have working hardware that's been, prototypes that's been tested in some of a similar environment. So we did vacuum testing. So that kind of helps to check part of that box.
Yeah.
But there's a bunch of nuances, and you can read about it on NASA's website. But so that's TRL. We want to get to, everything you do that gets you closer to that TRL 9 obviously means you're closer to being commercializable.
Yeah.
Or to sell to the government as an actual product.
Gotcha. And I'm, as an investor, far more likely to give you money if I see TRL 6 or 7 versus 3.
I mean, as you go up, it depends on what kind of investor you are, and how early in the game you want to get, because obviously if you're investing in a TRL 2 technology, you must believe in the team and the concept and where it could, and the potential.
Yeah.
And, you're probably gonna get more of the company. So there's always a trade-off with that kind of stuff. But, yeah, so you were asking me about SBIR. So that's the phase 1. Mm-hmm. And then after you win a phase 1, you can compete for phase 2. And that phase 2 proposal is due right at the end of the phase 1 when you submit it. So
gotcha.
Our phase 1 went in November, mid-November last year. We submitted that proposal. In March, or I guess in mid-February, we found out that we won our phase 2 proposal. So now we're on track. Now phase 2 is a 2-year, and with NASA, it's 2 years, $750,000. You have the opportunity to do, I think it's called an enhancement, 12 months in, where you can get some matching funding to increase the amount of money and maybe, if it's going well so far, right, and accelerate the progress to, even higher TRL level.
Matching from NASA?
Well, I mean, the matching fund, NASA will grant you some under the SBIR program. The other side of the match can come from outside investment. I think it can also even come from other government programs.
Okay.
As long as it's not part of the SBIR program.
Gotcha. So
there might be some details there that I don't have quite right, but that's, I think, the basic idea.
Okay, so that's actually a great transition. So if Space Force looks at this and says, hey, you guys can produce something that we can use as propellant, they may even come in and match some of those dollars.
I mean, I think it could be something like that, or it could even be another NASA department or another NASA program that's not SBIR.
Got it. Okay, cool. So then we've been dancing around it for a little while. How can you use metal as a fuel?
Right. So this is an interesting thing we discovered as we started to dig into this, and we're thinking about use cases. Because, when we first got it, especially when we first got it, it's still a question, but becoming less of an open question now, of who's your customer for all this material you're going to make in space. Great. Like, you can recycle space debris. That's wonderful. But who's going to buy it on the other side? Or are you just going to have this pile of processed material that's just sitting there? And, there's a little bit of we know that when it's available, somebody's going to find a purpose for it. And I do believe that's true, but you don't want that to be your argument.
Right. If you build it, they will come.
Yeah. The field of dreams argument is usually not the best one for investors. But, there is a little bit more to that in that, if you believe that space industrialization is happening, then you should believe that you need a metal processing capability, and then it's a matter of when is it happening. So you do need to believe it, and there's more things you need to believe too. But metal as a propellant came because we were looking for ways that we could use this material. And when we were looking in the very beginning, we were talking to people in Luxembourg. We came across this company that had a propulsion system, very small propulsion system, and they were using some kind of powdered metal as a propellant. I'm like, that's interesting. So that was the first time I learned about the possibility that metal could be a propellant. I didn't even know that metal could be a fuel for anything.
Sure.
Because it doesn't really burn, right? So that's sort of what I was thinking in my head. That's what fuel is. But it turns out that there's another company that, as we went further down the path, called Newman Space. They're in Australia. And they have advanced, rather old technology that I sort of learned about in a roundabout way as I found about Newman Space, which is called a vacuum arc thruster.
Okay.
And basically what it is in the Newman Space configuration is you have a solid metal rod. And actually this won't be good for people who are listening, but I can show you for the video too.
Beautiful.
I have some samples that we made. So these are very short. They would be longer, but like a solid metal rod like this, or you can look at that one. Yeah. And so this is this would be the propellant. And essentially what happens is there'll be a hole drilled down the center, and there's a sparking mechanism that goes up through the center that's insulated from the metal.
Okay.
And it creates a spark that touches the top surface of the metal. And it causes that wherever it touches, it's very high temperature plasma that gets created. It sort of turns that spot in a very quick period of time into plasma, and that plasma gets ejected out the back through magnetic fields, and that creates propulsion. And then as you do that, it kind of ablates the surface or wears it down. If you imagine like a candle burning down, it's not burning, but it's turning this metal into a plasma. Now you need to put energy into it to do that. So you're not burning it like rocket fuel, right? You're providing electricity to the system that creates the spark, and then that turns this into propellant.
So is it, what was the technical name? You said a metal arc?
It's a vacuum arc thruster system.
Vacuum arc. So is this similar heritage? It sounds like to an ion thruster, just with the fuel being, instead of a noble gas or something, it's a solid material. More
or less. I mean, that's essentially the idea. There's plasma thruster systems. This is one of those methods.
Okay.
Like Hall effect thruster is the one that people are most if you're in the space industry, that's the most tested and like successful system that people are using now.
Sure.
For its performance characteristics and whatnot. But it uses typically xenon gas, or the Starlink satellites, they use krypton gas because it's a bit cheaper than xenon, a little bit less performance, but still much cheaper, and more available. So anyway, that's a gas though. You have to keep a gas contained in a vessel.
Yeah.
And with a solid metal propellant, you don't have to keep it in anything special. It doesn't evaporate.
Yeah.
There's no pipes to pipe things around. There's other mechanisms like to reload these things or sort of advance them through as they're burning down and that sort of thing. But it has some advantages in terms of space and density to these gas-based propellants.
Okay, gotcha. So as I was doing research on this, because there's a whole camp of people out there that are anti-metal propulsion. And one of their shticks is that, well, when you turn that into a plasma, it's going to create a bunch of tiny bits of metal that are then going to come out and coat your spaceship with confetti. And you're going to have, which if you're only in space, maybe that's not an issue. Probably is still an issue for some performance issues. How do you mitigate getting coated in metal confetti?
There are some aspects of that we're developing, or the Newman Space is developing. We're sort of developing a partnership, which I probably can't go into too much. But what you're talking about actually is a very similar setup is used sometimes to do, what do they call it? It's like plasma deposition. Basically, you could put a target in front of that same setup and it'll coat it in a layer of metal.
Right. It's a 3D printing technique.
In a way. Yeah. It's usually used for much thinner kind of things that you're making, or coating something with a very thin, couple molecules thick or atoms thick layer of that particular metal, as far as I understand it. But I honestly don't know a lot about that application.
Sure.
But I think that's, the more common application for this type of technology, actually on Earth anyway. In space, however, when you I'm talking to Patty Newman, who's the original inventor of this version of this idea. He said that the particles, they're not particles when they leave they're like a plume of plasma. And then, in general, most of it is heading straight out in the direction of the thrust. And you can do certain things to it to try to focus that beam so that it's only going out that direction. And it's not spreading out in a big wide plume. If you put something behind it, yes, it would get coated with metal for sure, right? But if it's just going out into space, it is going to go out. It probably will eventually reform into very, very small, nanoparticles, but they're so small that they would either burn up in the atmosphere because they're at that right altitude to get captured by the atmosphere, or they're going to go out into deep space, or the solar wind's going to catch them and take them. It's not like you're going to create this pollution in orbit of this brown cloud of metal debris, that we're trying not to create.
We traded large space trash for
a cloud, right?
not fun whatsoever.
Right.
So partnering up with those guys, really as one of the main purchasers of the eventual products.
Well, actually, they wouldn't be necessarily the purchaser of the product. We sort of see ourselves with Newman Space as they're the makers of the combustion engine and we're the oil company.
Okay.
So we sort of need each other in that way. They don't need us to use to load their thrusters with metal that they make on Earth, obviously, that they launch in a satellite like any other kind of propellant. But if we want to create a market for refuelable Newman thrusters, then they need somebody to make that refuel, the rods to refuel them with, and we provide one of those capabilities for them. So we've formed a pretty close partnership and alliance in trying to move this technology forward for both of us. And so it's also an untested. It's not untested in concept. Their TRL level is actually quite a bit further than ours. I can't remember what the number is right now, but I can say that they have a scheduled test that they've announced publicly. I think it's supposed to happen either later this year, around the time of later this year. Obviously, launch schedules are flexible, but
just a little.
But they're on an Australian mission that has a bunch of different companies and university projects that are testing different things about different projects on one CubeSat. And so they're going to be one of those things. So they'll get some space heritage very soon with their version of this vacuum arc thruster. And that'll help us to. And we also announced recently on LinkedIn that timing isn't specified yet, but they did go into another agreement with another company in Australia to test out on 2 more flights, a Newman thruster in space. And on one of those flights, we're going to send up one of our rods that we make from recycled aluminum, simulated space debris. We'll make it here on Earth in similar conditions to what we would do in space, and then we'll be able to get a little bit of space heritage from that as well. So I'm not sure about the exact timing on that one, but relatively soon.
I love that. Yeah, it's interesting in the space industry. Like, one example is the Made in Space to Redwire story, where, for those that don't know, Made in Space was the premier actually in space manufacturer. They were the only ones.
They have 3D printers on the space station.
Right, still do. First thing they printed was a little logo. Gotta love it. But they've somewhat recently acquired by Redwire that has, I want to say 9, 10,
something like that.
10 other companies. And so it's just interesting within the space industry that because it's so hard and there's so many different unique verticals that have to be filled, it feels like at some point companies kind of conglomerate into a larger one.
This is a new phenomenon, by the way.
Yeah.
Yeah. That what you're describing in the space industry anyway. This has emerged in during the pandemic. Ironically, it's when these deals started to come together. So you have Redwire, which did, like you said, around something like 9 acquisitions so far. You have Voyager Space, which is doing something similar but has a slightly different approach. But the main point is, like you said, you're trying to take companies that have a specialty, and for the acquirer, obviously you hope that they have some book of business or whatever contracts lined up. And then you add them together, and then you have sort of the capability of a prime, but you have sort of the energy of a startup still, or a smaller company in each of these different entities that are put together. If that's how they describe it anyway.
Yeah.
So, but it's great for space entrepreneurship because until then, until 2020, you really weren't seeing that many deals and exits for space investors. I mean, there's been a handful, but not in the same way that you have many for other industries, right? So there was always a question of what are the exits that people are getting? Well, 2020 came along and you had, Redwire, Voyager. I mean, AE Industries, I think, is another one that I don't know if they're the ones that did Redwire. Actually, they might be the backers for that. But there's a couple other aggregators. And so you had those kind of deals. You had SPACs come out where companies were going public. Which is another whole topic, but
special purpose acquisition groups.
Yeah. Anyway, so there's been a lot of exits, and they help that process along.
Okay.
For all of us, if you can show your investors hey, look, these guys have been exiting, then it means that investors are more willing to put some capital at risk.
Okay. Yeah, and collaboration is good in there. Let me shift subjects a little bit. On a different podcast that I listened to, you talked about Elon Musk is, of course, an inspiration. I feel like that's the case for anyone in the space industry. One of the things you talked about was his commitment to first principles and how that really pushed him back in the PayPal, the Tesla, and now the SpaceX days. Could you give us a definition of how you define those first principles? And then how have you used that mindset coming into CisLunar Industries to really guide that post?
Yeah, so I think actually the first time I really thought about that approach was going back to that Peter Diamandis book, Bold. I don't know if that's where I heard it from him in that book or if it was from something else that he had created, but he also talks about first principles approach to things. And in a way, what it does is it frees you from, maybe I should define it first. So this is the idea of if you have a problem, instead of kind of going off of conventional wisdom and trying to go with, the way that other people have been doing it and solving that problem, you go back to the fundamentals of the physics of the problem. What is the real constraint on something that you're trying to build?
Okay.
Like if you were, I heard Elon Musk talk about this recently, actually, in another podcast, where the way he broke it down, he's like, if you were going to build a satellite, you know, you can ask somebody what the cost is going to be. They'll give you their rule of thumb based upon their experience, right? Which has got a lot of baggage about all the prior, like frameworks for costing out projects. And there's all these things that go into that aren't actually driving the cost really. And, if you take it to its fundamental nature, it's like, well, how much would the elements, if you were to take that satellite and divide it up into all the elements that are in that satellite on the periodic table, and then set a percentage of each, and then figure out how much mass you need of each element, and then go look at the commodities market and find out how much it costs to buy those elements. And then you had a magic box that you could stick those elements in, and it would make a satellite. It would just like reform those elements into, that's your actual minimum cost.
Fair.
Because you have to buy the raw materials, right? And then of course you've got people, time, and there's other minimum costs that kind of then start to go in. But the idea is that if you get really good at manufacturing something, you will approach an asymptotic cost, or like a minimum cost over time that is somewhere around the level or just above, a margin above that materials cost of the object. So you've got like a fully automated process, and it's all robotic, and like then it's just the energy that goes in and the materials you have to buy. Basically, that's your minimum, right?
Depreciation of the machines, but just a bit.
But I mean, yeah, that's right. You have to replace the machines and stuff. But again, like if you're just trying to figure out how cheap could it possibly get. And so that's like an example of thinking about first principles, because it's like, okay, space projects are supposed to cost, this huge number, but why? And so for myself, so that's just like an example of how it goes. Thinking about it that way, for me, does a couple of things. One is it allows me to sort of free myself from the thought process that says like, oh, I don't have any experience in the space industry. I don't, how could I start a space company?
Yeah.
And if you know that you can go back to first principles and think about problems from their essence, from their basic starting point, then you can kind of, like anybody from any background that's creative can either find people who can teach them about things, or can logic through some of this stuff and sort of build your way up to what the answer might be. And so it's just a way of like rethinking the problem and sort of breaking through the conventional wisdom that might keep you inside the box, so that. Yeah.
If your minimum cost is $5 million always, then you're not going to be able to come up with those innovative ideas.
Yeah. Or, like for SpaceX, the way that they're trying to build, a fully reusable rocket, previously, thought to be nearly impossible, or just like not ever going to be cost efficient, right? But finding different creative ways to solve the problem that makes it plausible, right? Totally shattering the paradigm of the cost structure for space. So yeah, I mean, for me, I guess that's the main thing. Like for me, it did two things. It gave me permission for myself to say, oh, I can go into the space industry, even though I don't have an aerospace background. And I've learned after I did that like actually you need all kinds of skills to be in the aerospace industry, and that's not actually as limiting a factor as I imagined it was. And then it's just figuring out what those minimum costs are. Always asking questions about like, well, why does it have to be that way? Because there might be another way to do it.
Okay, yeah, getting back to that, I appreciate it. So one of the things that I think it's a common trait that I've at least seen from the entrepreneurs that I've talked to and the ones that I've just read about, is just a persistent optimism, just like flows through their blood a lot of the times. Would you say that's true for yourself and those that you've interacted with, or I guess how does that ratio sort of balance out for you?
Yeah, I mean, I'm definitely an optimist. I think you can't really. I don't know how you would try to do something like this if you didn't lean that way, because, man, I mean, there's so many reasons to be pessimistic if you're trying to build a company. Like,
right.
There's all these risks, and if you want to let your imagination run wild in the negative direction, there's like a million ways it can go wrong. and you could running out of money or, an experiment not working the way you imagined it. But yeah, I if anything, I am too optimistic sometimes, but so far it's worked to my advantage. It allows you to, for me, it allows me to, like, even when things don't go right, to reframe my thinking quickly back to, okay, now how can we solve the problem? And when I look for people to partner with, either in companies we want to partner with or people we want to bring into the company, like, that is an absolute critical characteristic. If I don't want people to come to, there's a lot of challenges every day. Like, it doesn't do any of us any good to say that won't work because I have all this experience and this is why it won't work, because I've seen it doesn't work. It's more like, okay, if you're going to try to do that, these are the things that have to go right. Now, how can we make those things go right? Or are those things too expensive to make go right, or whatever? There could be some reason why we want to try a different way. But I'd rather take that approach than, just assuming it's not possible, right? So we're going to create a space economy. You have to believe, believe that science fiction can become science fact, and that's what you want to make happen, Yeah,
absolutely. I guess jumping into that, that's a good segue there. Are there any science fictions that have really, really spurred you on, got the wheels turning?
Yeah, it kind of changes over time as to what I'm into, right? What the most recent thing is, and I tend to like science fiction that is maybe not near future, like next year, kind of, or that is within the realm of what I could imagine doing in my lifetime.
Yeah,
I like to think about the other long future stuff too because it's fun, but there are some things like I think one of the best ones that's come out recently is The Expanse, as far as both a book and a TV series. And when I heard that they were turning the book into a TV series, I was very excited because I'd been consuming every one of those books as soon as they came out.
Nice.
And there's a little bit of magic in there too, right? But most of it is built up. A lot of it is built upon actual physics, and even the fusion drive that they use is also like, there's theory that backs up the possibility there, right? And so when I see stuff like that, or some other ones that have been interesting in the past, like is it the one Red Mars, Green Mars, Blue Mars? Did you ever do that series? A little bit older, but
was that the C.S. Lewis
space
trilogy?
It's Kim Stanley Robinson. I think it's that guy. I think it's that. I might be getting that wrong, but apologies if I did. But
we'll look it up.
But anyway, like, that one's cool because it's pretty hard science. It's about going to Mars and going through the process of colonization, and it does everything from the actual science behind how to do it to the politics of, like, should we preserve it, should we develop it, should we terraform, should we keep it pristine. So it's really interesting to think about all the different layers of how these things will unfold. And when I see something that's happening in science fiction that seems plausible, like, that's inspiration for how could we make that real? Could we make that real now? And I think throughout the space, the space development of the space industry, science fiction has always been an inspiration to engineers. And there's sort of this dance back and forth between sci-fi authors, like, telling stories and imagining things that then help engineers. And there's even been sci-fi authors that have consulted for companies on various projects. So,
yeah, you got to get inspiration from somewhere. Like you said, trying to build a brand new company from the ground up to solve a problem that no one's thought possible, that can probably be dark and depressing some days if you don't have the fire in you. And sci-fi is a good place to grab that from.
Mm-hmm. Yeah, for sure.
So, okay, sticking with the optimism train, let's say CisLunar Industries knocks it out of the park. All right, you crush the SBRI round 2. You even go to the third round, which is, and that's where you end up getting partnerships with outside companies, right? That's not mostly government money.
Yeah, like phase 3, they call it phase 3 on SBIR, but I don't think it's actually part of the SBIR program at that point where the funding is coming from. Generally, that's the transition to commercial, which could be contracts. If you're a DoD contractor, that could be DoD contracts, but, like, you're trying to commercialize this thing, make it more sustainable at that point. Now the numbers get much bigger. You're not talking about hundreds of thousands, you're talking about millions, to do certain projects at that point.
Okay.
Yeah.
So let's say that takes place, right? We're looking at, let's go to two time frames. We got 10 years and 25 for CisLunar Industries?
25 is it's pretty far out there. Yeah,
Kind of hard to predict, but
I mean, okay.
what's the dream there?
I mean, yeah, in my sort of vision of the future, what we're, I mean, this is the case that I actually kind of plan for, because that's what I'm trying to make happen, right?
Sure.
What's that saying? If you want a certain future, make the future happen. I'm not getting it right, but there's something about what's going to happen in the future. You make it happen a certain way, right?
You have. I've heard if you fail to aim, then you're bound to hit exactly that.
Right.
Nothing.
Yeah. So anyway, I mean, the way I see things unfolding, I think it can happen at a pretty rapid pace. We have expectations that we're going to have our commercial product ready by the middle of this decade. So, 2025, we'll have our first version of our Space Foundry ready to go. We'll have, at the same time, I expect the Newman thruster to be ready for prime time, and us have together maybe even already developed the whole refueling capability. All this stuff depends upon funding, but I think we can share this dream with investors and get them on board. And of course, that's also part of this vision.
Yeah.
And we have sufficient funding from private capital. We have support from the governments that are involved to develop and open up this capability. That we have all of the pieces of the value chain. So you got the debris removal companies and the in-space transportation companies, and then you've got the platform companies, and all these things are all coming together in the middle of this decade. And so then that would be number one is there. At the same time, we've got the moon being developed, right? We've got this sort of new race to the moon. I also, in my vision of what I hope will happen, is competition is great between, geopolitical powers, but let's not have any kinetic wars in space, please.
Yeah.
I mean, so in this scenario, nothing bad happens in space, but there's still a little bit of competition, which I actually think is healthy for this.
Yeah.
Keeps the focus there for Congress and the people funding these missions. And that will advance technology pretty quickly. If you look at the post-Cold War era, it was always flip-flop back and forth between the moon and Mars, and nothing ever went anywhere really. I mean, there's some progress, but so we see that unfolding. The moon developing, having people landing on the moon probably sometime in the second half of the decade, and starting to build those bases out there. We see an opportunity to deploy the Space Foundry on the moon as well. Okay. And whether that means that we're taking the same technology, which is I'm sure how we'll start it out, and then scaling it up with modular pieces, or eventually building a larger facility because we can't, because we're on the lunar surface, and we can start to take some of what we're making to build what we need to make. So I see that kind of scaling up there, and having an actual economy that's not just like an outpost like McMurdo Station at Antarctica, but it's actually developing into a tourism destination and
Sure.
a place to do manufacturing and to support a community that's actually living there, if not full time, rotating on a regular basis, always having people there on a permanent basis. I see that the costs to get to space going way down, which will increase dramatically the amount of usage of low Earth orbit.
For sure.
And in combination with what we're trying to do to make the retrieval of satellites at end of life, whether it's existing debris or new, not debris, but satellites just when they get to the end of their life, instead of having to deal with those by burning them up or whatever, we're actually bringing those on a continuous basis to our recycling platform. So, we'll probably have 10 or so, or maybe more platforms in different orbits in LEO that are strategically located.
Okay.
We'll have fleets of ADR spacecraft in hundreds that will go out and steadily, they don't have to be fast, but they provide a steady flow of materials, collecting those pieces of those satellites at end of life, bringing them to the recycling capability. And this really just this robust in-space economy developing. And really at this point when you have the lunar economy, you have an in-space economy, maybe you're starting to go out to Mars. You have a space-to-space business emerging. And I think that the optimistic case is that can happen sometime in the second half of this decade even. And so, we'll see.
10 years.
Yeah. I mean, now if you get out to 25 years, well, I mean, there's in that scenario, it's hard to know what happens past exponential growth, right?
Yeah, absolutely.
It could be hundreds of thousands of people in space, or it could be 1,000 or less. But I mean, I think the potential is there to start to expand out and really try to go out and spread humanity out through the solar system.
Yeah.
Maybe with some additional technological innovation on propulsion for interplanetary travel, we can reduce the time to get to Mars and back. So I don't know.
Yeah, it's hard to predict.
It's not like a financial statement that I can predict out, but I do think that like when we're recycling, when we get to the point where we can have, say, 30 microspace foundries in orbit, which I think we could do by 2027.
Okay.
That would enable us to process around 200,000 kilograms of aluminum a year, which is about how much we estimate is in, say, for example, like the Starlink constellation at 12,000 satellites.
Gotcha.
Well, not the whole Starlink constellation, the 20% that's being deorbited every year for their 5-year lifespan, right? And that they're just one example of many constellations that are out there. But
and that number's the percentage of the aluminum of that 1/5 or so.
That's the estimated mass of the aluminum of the fifth. Yeah. So if you take the 12,000 satellites times 20%, and then I think we estimate like something like 35% is aluminum. Then that's what you get, that around 200,000 kilograms.
Okay. Gotcha.
Yeah. So that would be enough to do that, and it would take about 200 space or debris removal satellites to go out and get those things. So we think we can create a whole value chain there that, pays for the whole process, basically makes the whole thing inherently economically sustainable.
And with those, you said the RDL satellites that are going out and grabbing that debris and bringing back, is that another company that you've similar sort of partnership as with Newman, or think there'll be multiple providers there?
I think that there will be multiple providers. It's entirely possible that it's likely that some of those providers will be acquired because they have a certain specialty technology that's really their secret sauce, and that gets added to one of the bigger providers. We did a demonstration last October with Newman Space, NanoRacks, and Astroscale. Astroscale is a debris removal company. They're certainly if not the most funded, one of the best funded companies in this area. They've done a space demonstration already. So they're the furthest along of the pure play, debris removal companies, but there's a number of other startups that have gotten funding already. So there's a lot of companies making progress on this front. And I think that market can be pretty diverse. So we may be going out to market and asking for bids on contracts to go get such amount of satellites for us, or we might partner with somebody and really specify like, okay, let's develop this together to make something that's optimized for this purpose. And they could be customers for our fuel rods, by the way.
Right.
So you had asked about. I just remembered that you had asked if Newman Space was a customer for us.
Right.
The customers are those spacecraft companies, and also the space stations too, because it's a good use case for station keeping or even moving the stations around to different orbits. So
now they don't have to ship up Xenon or Krypton and such.
Right. Exactly.
Okay. Gotcha. So I'm also wildly optimistic. Probably too much, but
rather err on that side than the other side.
Absolutely. Rather be optimistic and wrong than a pessimist and right.
Yeah.
But within that, there does have to be some level of not only rationality, but it
can't be blind optimism.
Can't be blind. Absolutely. So looking at maybe the 10-year goal, what are some of the stumbling blocks that you think are out there that you know of? Because there's probably a ton that are behind bushes or behind satellites.
There always are.
And you can't predict, Russia and Ukraine and geopolitical stuff. But the things that you can see that you're working to overcome, what are some of those
things
obstacles
that we can actually mitigate? I mean, you already sort of touched on the big ones that you can't mitigate, like some sort of devastating war. I mean, I actually think that's probably the only thing that could prevent the whole thing from happening, probably, which would, or some huge economic collapse. But both of those things are really out of my control. So, part of what we try to do is find ways that we can make what we're building useful along the way, so that there could be other applications if our main focus, is taking longer or whatever. Yeah. So, I mean, what you're talking about basically is market risk. And that's one of the things we can try to mitigate, right? By just positioning ourselves so that we don't run out of money and we have other sources of revenue. So, we try to think of what are we building that we can turn into a product in the near term. Mm-hmm. And there are some things that we're working on, like some of the subsystems we're working on could be potential products. So I probably can't go into too much detail about the specifics there, but there are some that we think could have ready markets already in the satellite industry.
Okay. Not Earth-based, but
maybe even Earth-based actually. But for now, if we can sell it into the satellite industry, that would be better because then we're building for space, sell to space. Yeah. So we've looked into some terrestrial potential opportunities in the past. Like one of the things we investigated for about a year was e-waste recycling, and could we leverage some of the technology that's being used to extract gold and other precious metals from electronic wastes like circuit boards and that sort of thing to refine metals in space, which we do want to be able to do eventually, right? Gotcha. For the most part, that experience ended up being kind of a distraction, and it proved to be a difficult business to get into. But it was a good exercise to figure that out, right? But that said, I think we keep on our horizon always like, what could we license to industry? Could some of the processing techniques we're using improve terrestrial metal processing? Because really, like terrestrial metal processing hasn't changed that much in a long time, and that's because like it's relatively inexpensive to do it the way it's going, and we know how it works, and so there's a whole industry built around that. That doesn't mean there's no opportunities for disrupting that. And if we're doing it for space, maybe we can use that for some other application. My preference in that case is to find like a partner that we can license our tech to and let them run with it if that opportunity arises. So that's one thing. The other thing is, the other thing we do to like try to mitigate risks, and this I think fundamental to our approach towards this whole idea, is to try to work with as many partners as we can and sort of build this coalition. Because right now, this won't always be the case, but right now, this new space economy that we think is unfolding is really like a blue ocean. I don't know if you know this term, like blue ocean, red ocean. Red ocean is where there's a lot of fighting in the water, and so that it turns blood red, right? Because there's a lot of cutthroat competition. In the blue ocean, it's just wide open. And so that means that there's enough opportunity for all of us to make money, especially in the beginning, and that we can actually get there faster if we collaborate. Weird. So to that end, also because we're small, we don't have a ton of capital at the ready. We really have to partner with companies who are already developing these things. And I talked about the ecosystem before. So we've tried to find the companies that are doing the most innovative stuff here, build strong relationships with them. I mean, being able to do that has really been one of our skill sets, to go out and make those friendships, find ways that are mutually beneficial, where we always try to find a way that we can help advance the other company's work, by something with us where we can highlight what they're working on, which also helps to highlight what we're working on. And if we can do that, build that coalition, that it creates, I guess, like a team of companies that are all pushing for this future economy that we all benefit from. It allows us to accelerate the progress. It allows us to, you talked about the risk of relying on other companies to do other parts of the value chain, right? Mm-hmm. Well, if we're helping them get there, then we have some level of influence on like, hey, let's get this, let's propose a demonstration where we can show how this works. And that helps us kind of guide that process to things that we want to see happen. That's beneficial to everybody. So I think that's probably our biggest strategy for trying to mitigate the risks that we can.
Okay. But then on like a technological level.
Oh yeah.
Right. So you're at TRL 4 as of right now?
Yeah, probably about 4.
Okay.
Yeah.
About 4. Are there some elements of maybe like the contactlessness?
Oh yeah, sure.
That haven't been.
Yeah, there's going to be a lot of technical hurdles to overcome for sure.
Sure.
And the thing is, we try to keep it in such a way that it's not inventing something like new physics. We're trying to adapt existing techniques to an industrial capability. So I mentioned the electromagnetic levitation furnace on the space station.
Right.
used for materials research. Well, we're taking the same concept and sort of upscaling it, increasing its size for a different purpose. But there's a lot of data already about how different materials behave in this kind of environment because of the work they've been doing. So we can leverage that. And then there will be things that, it's just going to take a lot of engineering and testing on orbit, actually seeing, for example, there's some things that we just have to go to orbit to find out. Mm-hmm. So we can show how we can make wire, we can make, metal rods on Earth, but what we don't know, and like there's some indication from the research that's been done, right? But we don't really know what the grain structure and how the final rod is going to be, how the material is going to end up after we cast it in microgravity. And we do that for, a whole week straight. We just keep making rods. Like what happens to the machine? What does the material look like? What can you use it for? What additional processes need to be done to it to make it useful for this or that purpose, right? Mm-hmm. And so, we have on our roadmap to go to the space station in like the late 2023, early 24 timeframe, where we can do that kind of testing over the course of at least a week. Nice. And then we can come back with the materials and say, okay, this is the material we can make on orbit. If you're the manufacturer of something on orbit, could you adapt your machine so that it could use this kind of material? Because to this we can make on orbit. We might not be able to make this thing that you've been using, that you've been launching from Earth, but we can get it for you much cheaper if we make it on orbit. And so then you open up possibilities for that, right? So that's like part of the technical risk buy down, doing parabolic flights. You can learn some things from that as well.
Sure.
And we will do that as well before we even go to the space station.
And that's this year, right?
We're aiming for the end of this year as our first experiment on a parabolic flight. Yeah.
Okay. Nice.
So that should be fun. So there's that opportunity. And then, of course, there are things that we imagine like that we just haven't really dived deep into yet, which is like the robotics for taking apart an old satellite.
Yeah.
This could be a challenge. It will be a challenge for sure. It might be less of a challenge for the new satellites that come up because maybe we can even collaborate with some of the manufacturers so that they design them in a way that makes them easier to take apart, or they have little tags that help the robots understand what's what.
Sure.
Like pull this copper wire from this piece of aluminum, skin or whatever.
Yeah.
But like the old stuff, it might be brittle because it's been in radiation environment for a long time, or there's a lot of unknowns out there.
Sure.
And until we go and try to do something with it, we really don't know exactly what's going to happen.
Yeah.
So, thinking about ways to mitigate those will be some of the challenges for sure.
Okay. Gotcha. And even within that, it's a startup. And so, yes, eventually we want to make returns for our investors and build that bustling CisLunar economy. But that takes time, and you're going to need a lot of those investors to stick with you through testing material, and then it breaks in half right before you put it into the machine. I guess besides just the what would you say to investors that are saying, "Hey, I like space, but I'm really trying to get some returns in my portfolio. Why should I even give my money to you guys?"
Yeah, there's a couple of reasons there. Like, what are the alternatives for investing in space, right? There's different major areas. And I think if you look at the things that have already been kind of not done all the way, but are pretty well mature and now kind of saturated, you've got, launch is pretty saturated.
Yeah. Oh my gosh.
There are, I don't know, maybe 200 proposed launch companies. We know that most of those won't make it at the end of the day.
No.
But so that's an area where I think the returns are less significant. It's already dominated by one, major player in SpaceX, of course. And then you've got the next thing is sort of Earth observation satellites, also pretty saturated. Now there's still things that can be done that are new there, right? But I think that these things, if you're more conservative investor, that's where you should probably go. Those areas where you're looking more for cash flows and things that you can sort of analyze on a traditional basis. The next thing that's going to happen, that's already starting to happen, is this in-space manufacturing, on-orbit servicing assembly, this OSAM part. That's why NASA is really interested in this. Yeah. Space Force is really interested in this. It's a capability that we need to stay competitive with our geopolitical, rivals.
Sure.
And so there's a lot of foundational impetus to keep that part going from the government side. And we're seeing capital flowing into it already. So that's just like putting us in the area that we're in, right? But then for CisLunar Industries, what we think is critical here, and why, of course, we think our investment is attractive.
Yeah.
And just to be clear, I'm not promoting any investments right now, for the record.
This is not financial advice.
It's not at all. But, you know, for the investors that have invested in us, I could maybe talk about their motivations, right? They see that there is this industrial revolution happening. It's probably already started, or it's just beginning to start. And you won't really know that until you look back in 10 years, right? Mm-hmm. But the pieces of the puzzle are starting to happen. The technologies that weren't available in the past that could enable us to actually create a recycling ecosystem are about to be real in a few years, okay? So because of that, now is a good time to create this capability. And we can take this capability that we're building to process metals and use it to help solve the debris problem, which is becoming increasingly difficult and at an exponential rate. So we need more than just, it's a Superfund site, we got to spend a lot of money to clean it up, because that is not sustainable. No. I mean, as soon as you have a change in the political winds, that'll stop getting funding, right? Mm-hmm. You need something that drives itself forward from a self-sustaining economic basis, which is generally, I need to find a way to make a return on my investment, okay? So put us in the middle of that problem, and we convert this, you know, challenging mess to clean up into a valuable mine that we can extract resources from to accelerate the development of this in-space economy, help pull forward all these other companies. We put ourselves right in the middle of that value chain and that argument. We are the thing that turns that waste into something valuable at a lower cost, creating capabilities that can be used to make very large structures, because the same processing can be used to sort of extrude very long beams and things. And then we lay the foundation for that processing technology that helps us convert debris into something valuable as the industrial capability for metal processing in this new industrial revolution. So now we become the steel mills and the aluminum smelters of the 21st century. And that's why we think our investors who've come in so far are interested. That's why I put my time and energy into the project. And we think that, you know, I don't know, for investors always want to have a return on their investment. For me personally, of course, I hope to make money off of everything that we're doing, but it's really more about, if we can do what I just described, then we will help to advance humanity's expansion out into the solar system. We will be able to enable people to live further and further away from Earth with the same capabilities we have. And to me, like, that's the optimistic scenario for humanity, is the expansion out into the solar system so that we can get the resources we need out in space. We don't have to worry about the limited capacity of Earth. We don't have to worry about the limited carrying capacity of Earth in terms of population. Sure. There's basically infinite room for humanity to expand if we go out and we find a way to live out in the solar system. And those benefits will accrue back to everyone at Earth too. It's not like the space people will get rich and the Earth people will stay poor. No, all this stuff cascades down and creates a prosperous, you know, technologically advanced future for all of humanity.
Elaborate on that part a little bit for me, because that was fantastic. I love tracking with you entirely. A lot of people in the space industry, for example, they saw Virgin Orbits just release public sale of their 90-minute flight up into space for the low price of $500,000 for 90 minutes.
Right.
And the space industry people said, all right, about time.
Right.
And everyone else said, are you out of your mind? That's insane. When you're in the industry, 20 years ago, I'm forgetting the name, but private astronaut went to the space station, was there for a week or whatever, cost him $25 million, something insane. And he got a good deal because there was an open seat. Mm-hmm. And so $500K is actually really, really cheap. And so if you have the framework, the verbiage, you realize that price has decreased dramatically. And then that's probably going to bring a lot of benefits to the rest of mankind. But that's something that the average Joe who just flips on, SpaceX blew up another rocket.
Mm-hmm. Right.
They don't get that.
Right.
So as
And
best,
the media also picks the most
yeah.
sensational things to print about it too. That makes it even more controversial. Right?
For sure.
But that's their job, I guess. They get ratings. I mean, I don't really think that should be their job, but that's like ends up being what it is.
that's what it's turned into in the last 20 years.
Yeah.
So yeah, I guess digging into that, and this will be one of those consistent questions that I really want to ask a lot of the academics and the engineers out there and executives like yourself. How and why? Like, how does this process of CisLunar Industries, that 10-year incredible perspective that you just painted, why should Joe the plumber even care?
Right. And it's especially difficult for them to care if it's like, oh, some billionaire built his rocket and you know, it's just like a toy for the billionaires that are seeming more and more disconnected from the rest of society. You know, and there's plenty of good reasons for people to feel that way, I would say. But what any people have a hard time doing, including myself, because I'm a human, like it is seeing things that are exponential. Our lives run in a linear fashion. Things change gradually from our day-to-day perspective. But if you look at the sweep of history, technologies, especially in the 20th century and now in the 21st century, have grown exponentially. You look at computers, you can see that like the supercomputer that, you know, ran like the space missions of the 70s is much worse than like the crappiest cell phone you can buy right now. So, you know, that has benefited all people in society, not just the wealthy. But I remember, you know, back in like when cell phones became a thing, they were extremely expensive. They didn't work that well. You know, it was something for like, there was always like a meme of like a Wall Street banker walking down the beach with his giant brick phone, you know,
Yep.
buy, sell, right?
Yep.
And then now it's the common man's communication device. It's a way that information gets to, you know, like people who were, you know, totally disconnected from information in rural areas in all parts of the world now. So I don't know if that argument resonates with, you know, people in the moment, but like space travel, and also it's important to note that not everybody wants to go to space.
Yeah.
I don't know what the percentage is, but I mean, if I survey my friends, like, you know, who aren't in space industry, right? It's probably maybe half of them want to go to space.
I've gotten like 20%.
Maybe 25%.
Yeah.
Well, maybe 20% like, yes, I definitely want to go to space. And then there's another 20% like, maybe I'd go if it was free or like if I had the, maybe.
Yeah.
It seems risky. And then there's like people like, nope, have no interest in going to space. Like my wife is one of those people. I have a very good friend who's like, I'm an Earthling. I belong on Earth. I think we all belong on Earth. Good for you. I'm happy for you, but I don't have any interest in going to space.
I'm an Earthling.
Yeah. So there's that, which makes communicating about the benefits of space hard for some people. But
Sure.
the other thing is it's very opaque to people is just how much you use space, like from the moment you wake up every day. The typical citizen in the United States is like, our whole modern economy runs on some layer that goes through space. And so, you know, technologies are developed to achieve these goals, even like the expensive tourist space flights. It's a starting point. Like air travel, also when it became an actual jet travel, was a very expensive thing in the beginning. And now it allows, you know, most people to be able to, you know, afford a plane ticket to go anywhere in the world if they like want to save up for it. I mean, some people can't do it, but like it's accessible to the general population, right?
Vast majority.
Space will get there eventually. And it starts with wealthy people. Usually these things start with wealthy people who have money to spend, like to advance these technologies. That's what enables it to have a market so that it can get cheaper. Right. And so this is just the starting point, and it will go down. And when you look back, I'm sure you could apply some sort of exponential price drop curve to this, to space travel, just like you can to computers and like all these other technologies that we get very cheaply now that have benefited our lives. So, I mean, there's that aspect, and then there's the aspect that I mentioned earlier when I was talking about how, you know, where I thought it could go with, you know, how I envision an expansive future for humanity. And I think the only way to achieve that is to go out into space and find ways to make that happen. So that's the other reason why, you know, anybody should care about this, making this reality. I mean, it creates an inspirational, optimistic future for humanity instead of a, you know, constricted,
Stuck on the planet.
yeah, Well, I mean, not even stuck on the planet, but just constrained by the resource limitations of Earth. Earth only has so much resources available, so much carrying capacity for population. Like, we need to find ways to either expand that or constrain what we're doing. And I mean, if we want to solve climate change, it's got to happen in space. Like, part of that solution is going to be in space. So there's a lot of things there.
So at the end there, you just mentioned something that I really love. In fact, I talked with a guy on the plane ride over here about solving climate change through space applications. Talk to us a little bit about that. Is your mindset of, hey, CisLunar Industries, we could build the truss structures that would then have space-based solar power and beam that on down? Or are there some other innovations that you've got brewing around in your brain?
I mean, there's different levels of sci-fi around some of this stuff.
For sure.
And I think actually there's no physics that stop us from doing any of these things. It's just a matter of like will and application of capital, basically. But yeah, space-based solar power is a relatively near-term possibility that some of the basic capability, like technologies needed for it, have been demonstrated at some level. There are a number of like projects, space flight demos that are being planned either by the Space Force or NASA or other agencies to show some of the basic capabilities that China's proposed also their own space-based solar power. So if you don't know what space-based solar power is, it's the idea that you can basically put solar panels in space to collect energy from the sun. It's you get a much stronger, it doesn't have to go through the atmosphere, so the rays are much more intense. Mm-hmm. You get more power density from the rays that hit the solar panels, and then you beam that down to Earth, usually with microwaves is how they're doing it. I mean, there are some questions in my mind about like, well, what happens if, say, a bird flies through that microwave beam? Do they get cooked? I don't know. Yep. I'm not really an expert on space-based solar power in that regard, but there's been a lot of research into it. Mm-hmm. And it's a plausible way to deal with the world's energy needs by having orbiting satellites, very large structures that have lots of solar panels on them that then beam these down to stations on Earth. And then you don't need to burn fossil fuels or nuclear power, any of that stuff terrestrially, just beaming it down. The sun always shines in space. That's kind of how they think about it. But for CisLunar Industries, it creates an interesting opportunity because if you want to build space-based solar power, you need materials and large structures to do that. Mm-hmm. And one of the things that's always held back space-based solar power is this idea we'd have to launch all of this structure and solar panels into orbit in order to do that. So one scenario we've been tossing around is, well, we've got these mega constellations flying around. They have solar panels on them. They have metal in them. If we, one of the potential outputs of this is we could harvest the solar panels, assuming they're still functional, right? And then the metal, build trusses or some sort of structural, component with the metal that we harvest, salvage the solar panels, and maybe even use those solar panels to start building out this space-based solar power. Or maybe it's not the core of it, but it's a way to extend it, or something like that. Yeah. Which is kind of interesting because you're already launching those materials for a different purpose. And then when they get to the end of life, they can then become an extension to a space-based solar power plant. I mean, that seems kind of interesting. Yeah. We haven't vetted the full feasibility of that, but it's an interesting idea for either way, we can still build the truss structures for these space-based solar power plants. So that's kind of a cool application that's could affect climate change because you could get rid of any carbon-based, power plants. And also even, I think nuclear should be one of our solutions, but that's another whole conversation. But nevertheless, you could avoid using any other power supply, basically. And you could also beam it to very remote locations too. So you don't need to build out any infrastructure on the ground, which is also kind of interesting. I guess the same way you deliver communications through cell phones without ever laying down any phone lines in some countries that never got to that first stage. They just went straight to cell phones because it's easier, to build it out that way.
Yeah, I feel like a lot of this whole talk is just, there should be a little symbol, right, floating here. This is just reduce, reuse, recycle.
Indeed, right? And like, I like what I like to say, people sometimes ask us about, well, what are you going to do with the stuff you can't use? Mm-hmm. Well, eventually we want to be able to, as they say, like eat the whole buffalo, like use all parts of the satellite, all the materials, even the plastics and stuff there. And maybe there's a way to reuse that material, even if it's like a filler for a radiation panel or something like that. There's different ideas that people have floated to us for different materials that are out there.
Gotcha.
Metal's the easiest one to deal with at first. And in the beginning, we'll have to deorbit some of the waste probably periodically, but we can eventually get there. So salvage and reprocessing are the two ways we're going to try to do that.
Yeah.
The other one that's interesting is, and this is more like, okay, we've gone a little too far with climate change. We need to do something to like cool down the earth, basically. And there's a number of geoengineering concepts out there, but one of them that's space-based that's interesting is putting a solar shade out at what's called the Earth-Sun L1 point, which is a stable gravitational point between the Earth and the Sun, where the pull of the Sun balances out with the pull of the Earth, so things can kind of stay there in a stable orbit without having to use a lot of energy.
Yep.
So
Nice.
one thing you could do potentially in space is make thin metal film that could be used as that shade. And if we're recycling metal, we could manufacture this thin film either in an Earth orbit or even out at the L1 point at where they're building it. This was probably a better way to do it, and build that kind of structure. This would be a very large structure. It would require millions of tons or millions of kilograms anyway of material to build anything that has any impact. Right. But the cool thing about this strategy versus other geoengineering strategies is you can turn it on and off.
Yeah.
So if it's like having some sort of detrimental impact, you just flip the shade so the sun comes through again, or you disperse the satellites if it's really too dangerous and you can't control it or something. It's not like it's going to be one giant thing in the way that you can't move. It's going to be many smaller ones probably. And there are outfits working on this stuff, like serious people who know about this stuff. There are groups. There's a group, I forget what the Sunshine Foundation maybe even, but I forget what they're called exactly, but they're working on how to do this problem. And so that's a good solution. It's probably better than, say doing like, releasing aerosols into the stratosphere so you can like try to create like a volcanic eruption type of effect where it cools down the earth. Like that probably also would work, but who knows what the other negative consequences might be.
Might be some seagulls dropping. If we do that.
Yeah, and imagine if we do a project like that to try to reduce the temperature on Earth, temporarily mitigate this while we get the other, the emissions and stuff under control.
Sure.
You build something that big out in space, you're going to trigger a huge economic expansion in space.
Great point.
So there is, it's like a public work project, but it would be a very important one. It could be a great opportunity for international collaboration, like the space station has been, up until now, and like that's helped. Being able to collaborate in that way has helped to avoid conflict, and so there's a lot of reasons to try this sort of thing. It just strikes most people as like, what? You're gonna put a giant sunshade between the Earth and the moon, or the Earth and the sun? Like,
what are you doing?
It sounds impossible, So they're going to need to market this one and really sell it. But it is technically feasible. There's not really anything necessarily stopping us from doing it.
One of the really futuristic yet physically possible sci-fi ideas that I really love comes out of The High Frontier, which was like Bezos's inspirational book written back, I think really early 70s. And Gerald O'Neill, this physicist, he asks the question, as humanity expands out into space, are planets or the moon, is that the best place for us to live on Mars or on the moon? And no.
Well, that was the answer they came up with.
That was the answer they came up with.
At Princeton class that he was teaching. Yeah.
Right. Yeah. Thank you. And so instead they proposed these massive, 5, 10 kilometer long and other sized cylinders that would be rotating in space so you can get one gravity. Moon doesn't have that. And they could be all different types of environments on the inside. And to me, that's a really optimistic.
I love that outcome at the end. Like that, and actually, you can create a lot of surface area for people to live on by doing it that way, and they can be positioned near Earth.
Yes.
So you can make easy trips, to Earth and back. So like mining the moon for metals is a great source of materials for that kind of thing. And, asteroids will also be probably a source, but like the moon is right there. It's the perfect place to get a lot of these metals from to build and the gravity is relatively low there. We can also set up a lunar elevator with current technology. Like you don't need any special materials to do it, which could be used to lift all this material off of the Earth too. I mean, there's a lot of interesting feed down, projects that help to build something like that. But I think I see that as like a likely outcome as one of the places people live in the future.
Yeah.
If we get to my optimistic, future, then that's one of the places people go. Right?
Yeah. One of my dreams is by like 85, 90
to go to an O'Neill cylinder.
To go to an O'Neill cylinder.
Totally. That would be amazing.
That'd be awesome.
I mean, there are, there's a company called Think Orbital. Have you talked to those guys before?
I've chatted with them. Going to get them on the show soon.
Okay, well, they have a really cool technology idea for how they want to do it, and it's conceivable that their approach could be used to build something like an O'Neill cylinder someday. So I mean, people are working on it. That's the cool part.
Stay tuned for future episodes. We'll chat with them. Love it. So as we're wrapping up here, Gary. At this point, you said 2017 is when you first were formed.
Yeah, 2017 out of the ISU Space Studies program that I did in Cork, Ireland that year.
Okay. So 5-6 years, depending on when in that you guys have been around. At this point, what's really the help that you guys need?
I mean, so we are getting a lot of momentum right now. We just won our phase 2 for our NASA SBIR.
Right.
Obviously, like all startups, we also need funding, so that's part of the puzzle, of course. But we also are going to need talent. We're going to need people who have ideas of how they can use these materials, because we don't want to have the field of dreams approach.
Yep.
So obviously, we talk to companies we think might have those, but of course, if anybody's out there who has I have a mission, if you can get me materials in space, this is what I want to do with it. We always want to hear that stuff. And we're always looking for partners who think that we can, help each other move forward faster. So partnerships, and talent. There's going to be a lot of interesting jobs that are in CisLunar Industries that we're going to need filled. And we're looking for, we're building our A team out right now. So there's going to be opportunities there. So it's really like startup. What do we need? We need people.
Yep.
We need money. We need sales.
That'd be nice.
So all of those things are part of the puzzle. And
cool.
I'm always happy to talk to anybody about any of those things if there's interest. Right.
He's very open. When you communicate with him on the internets. Where can people continue following you? Is it just going to be LinkedIn on the website, or what should they be waiting for, looking forward to for a big, I'm an investor.
Mm-hmm.
I don't want to get at this level. I really want a little bit more of the idea flushed out.
Yep.
What's the next thing that they should be looking for?
Well, there's where should they look, and then what should they be looking for, right? So yeah, I mean,
give me both.
We're on LinkedIn, of course. That's where the space community seems to do most of their posting and stuff on that platform for this kind of stuff, announcements and things like that. Of course, our website, we continue to build that out and add more content there, those are we can email us, of course, and I do my best to respond to those in a timely fashion. But
maybe at 2 a.m.
It all depends on what else is going on sometimes for how long it takes. But I guess what to look for is we're kicking off our phase 2. I mean, we're under contracting now technically at the time of this taping, but I have no reason to believe that any reason we wouldn't finish that process. So we should be kicking that off relatively soon in the spring. And what I would look for as we go through this is, some of the announcements we'll make as we, secure patents and IP protection for certain technologies we're working on that are going to really advance the capabilities we have. I can tell you that we've already made some significant progress since our demo that we did back in October. So we're going to look for more opportunities to do those demonstrations. Look for a parabolic flight in about within the next 12 months, somewhere around there.
Yeah.
And really, we're also, of course, proposing to the Space Force for some of their solicitations. You never know how many of these you're going to win, right?
Sure.
But we'll announce them when we do.
Cool.
And every time we get one of those, that's just another proof point that the government is behind it, and partners are behind it. We're lining up more partnerships and LOIs and that sort of thing to secure those other pieces of the puzzle that we're trying to put together. And there's some really interesting ones that we're working on right now. So keep an eye out for some of those announcements, because some of them will be pretty interesting.
Okay, nice. Might have to ask about those off tape.
Yeah.
Gary, really appreciate it. It's been a pleasure chatting with you today.
Yeah.
And thanks for having me over here in Denver.
Yeah, thanks for coming by. It's been a great time. Enjoyed it a lot.
Awesome. Appreciate it. Cheers, everybody. Go outside, enjoy some blue sky, drink some water like you've been hearing me doing this whole show. And ad astra. Cheers.
Thanks.
Thank you all for listening to the show. We really appreciate the support. If you got some value out of this, drop a review, leave a couple stars. Let us know what we can improve on in the future. Constant student, want to know my flaws, want to work to improve them. I'm sure Jocko Podcast and Joe Rogan, if you've watched or listened to any of those, they've had quite the improvement train. So this is episode 1. Looking forward to where we will be at episode 500. If you want to reach out, LinkedIn is probably the best place to find me at J. Vincent Maroli. On there's a link out to my website, to the email that my co-founder Ryan Tiller did a phenomenal job setting that up. Big thank you to you, Ryan. If you're looking for some next steps on how to actually invest in these various space companies, go to the website CisLunarEXP.com. There's a consulting tab in the top right. Jump on there. There'll be a little Zoom session that the two of us can jump on, and I can get you in touch with some pretty incredible resources out there, doing crowdfunding as well as more of the accredited investor side of the investment channel. So jump on there if you're interested. Anyone else still listening, thank you for your time. Don't forget to aim and aim high. Blessings to you all.